In this video, we're going to talk about whether or not the 6 trig functions, each one of those, we're going to check them to see if they're even or odd functions. Now, to do that, I want to do a quick refresher on what an even function is and what an odd function is. This is the function x squared. This is considered an even function because if you recall, an even function means that if I switch the input, the sign of my input, the input is what I plug in for x, or my independent variable. If I plug in a different sign, switch the signs of my input, I'm still going to get the same output. These are going to be equal. So, for example, if I plug in 2 or if I plug in -2 into x squared, I'm still going to get out 4. So if I start off with an input of 2 and I get out 4, here's my output. I'll label this as output. Whoops. Here's my input for 2. And then I switch the sign of my input. I'm still going to get out the same output. Okay, so an even function is if you switch the sign of your input, you're still going to get out the same y values or the same outputs. Looking at an odd function, this is x cubed. An odd function means if you switch the sign of your input, your output is going to switch signs. So in this case, if I plug in, say, -2 into x cubed, that's going to give me -2 times -2 times -2, that's -8. If I switch the sign of my input, so it's originally -2, so if I switch the sign of my input and I'm put in +2, that should also switch the sign of my output. So if I take 2 times 2 times 2 and I cube it, I get 8. So look, if I switch the sign of my input, it switches the sign of my output. That's an odd function. All right, so now let's relate this to our trig functions. So recall that the definition of sine is y, cosine of t is x, tangent of t is y over x, cosecant of t is equal to 1 over y, secant of t is equal to 1 over x, and cotangent of t is equal to x over y. So we're going to test this theory. So if I plug in for my input, if I switch the sign of my input, in this case our input is our angle because we're talking about trig functions. I want to see if my output switches signs. Okay, so looking at a -t, angle, if this is +t, then going in the reverse direction would be -t. So I'm going to look at, when I plug in -t into my trig functions, this is the point that I'm looking at for my x and y coordinates. So if I plug in -t for my angle, my y coordinate would be -y. Because I switched the input from t to -t, and I noticed that my output switched from y to -y, that tells me this is an odd function. If my input switches signs, then my output switches signs. Okay, let's test it for cosine. Cosine of my negative angle t, that's my x-coordinate, and my x-coordinate at -t, at that angle, when it sweeps open, is x. So if I plug in +t or if I plug in -t, my output stays the same. That tells me that this is an even function. Let's test it for tangent. If I plug in negative t for tangent, I take my y coordinate over my x coordinate, which would be minus y over x. Notice, here it's positive, here it's negative, so if I switch the sign of my input, the sign of my output changes. So that means this is an odd function. Let's test it for cosecant. If I plug in a negative t for my angle, cosecant is the reciprocal of y, my y coordinate. So that's 1 over negative y. So if I switch the signs of my input, notice that my output signs change. It's the same exact value other than the sign changes. That tells me the cosecant is an odd function. Secant. If I plug in a negative t, so if I switch my input, secant is the reciprocal of my x coordinate, so that's 1 over x. If I switch the sign of my input, notice that my output stays the same. That means this is an even function. Last one, cotangent. I'm going to replace t with negative t. I'm going to plug in a negative angle, negative t. So cotangent is the x-coordinate over the y-coordinate. The x-coordinate is x. The y-coordinate is negative y. When I switch the sign of my input, my output changes signs. That tells me the cotangent is an odd function. So what I want you to notice is that all of these functions are odd except for cosine and secant. Cosine and secant are the only trig functions that are even. Everything else is odd. Okay, let's apply this. How is this going to help us? First example, if the secant of an angle t is 2, what is the secant of negative t? So if secant of angle t is equal to 2, we're looking to see what secant of negative t is. I know secant is even. It's one of the two functions that are even. Secant and cosecant are even. Secant and cosine are even. That means if my input changes signs, my output stays the same. So here my input is changing signs, which means my output stays the same. So I know that secant of negative t is 2 if secant of t is 2. Now looking at the second example, it's saying tangent of angle t is 1. What is the tangent of negative t? I know the tangent is an odd function. That means if I switch the sign of my input, my output needs to switch signs as well. So if I switch the sign of my input, I will go from t to negative t. My output needs to change signs as well. So this needs to be a negative 1. So that tells me that I know the tangent of negative t is equal to negative 1.